Okay, so it's some sort of pulmonary and then it's bringing back from lung, so it's vein. Good job. Alright, aorta. Oh, it's 15 now. 15 is this structure over here, this chamber. Okay. Okay, so right atrium, below right atrium, right ventricle. Next one. Yeah, I believe most of y'all should be getting the next one right too. Good. Okay. Hope it's accidental. Next, the valves. What is this valve over here? Separating the right atrium and the right ventricle. So is it tri or bi? Again, the trick here is right side, so tri. We don't want RI, tricuspid valve. The next valve, structure 13. Structure 13. Is this valve over here? What's the name of the valve separating right ventricle from pulmonary artery? Okay, pulmonary valve. Just follow the name of the blood vessel. Next, valve, structure 6, separating left atrium from left ventricle. Okay, bicuspid valve. Last but not least, the valve separating left ventricle from aorta. Okay, aortic valve. Okay, what's the matter? Okay, double points. Why is the wall of the left ventricle so much thicker? Why got so much more muscle? Okay, so this was not taught to you outright, but it's an inference question. Because you need to pump blood to the rest of the body, so you need a lot of power. Okay, next. What's the function of the valves? There are two answers here. Okay. the valves do not channel blood in one direction. It's just like a door. Okay, the door cannot channel you in one direction. However, the opening can channel you in one direction. Yeah, all you had to do was look at the whiteboard. Okay, where does blood bring where does the pulmonary artery bring blood to? Brings blood to the lungs. Always, if you see word pulmonary, it has to do with the lungs. Where does blood leaving the aorta go through? Yeah, same thing, just need to look at the whiteboard. Okay, where does blood bring? Where does the vena cava bring blood from? Brings from the rest of the body. Okay, you must get very familiar with this. Last one, see the word pulmonary. Where does that associate with? Yeah, I really hope you all just press wrongly. Okay, where does blood bring? Where does the pulmonary vein bring blood from? You see the word pulmonary always has to do with the lungs. Vein will always means coming back to the lung, coming back to the heart. Okay, so that's the structure of the heart. Congratulations. Okay, good. You keep up the revision. Okay, then we'll practice this over and over again until you get very familiar with it. Today we're going to continue on with what we did last week. Last week we did this, right? We did the structure of the heart by playing the pumps. From the pumps, we figured out how the heart roughly works. We learned that there are two valves that help you understand how the heart works. Last week, you have drawn already a diagram, a rough diagram of how the heart works. Okay, so we're going to skip this portion over here. Instead, today we're going to try to interpret, we're going to try and move to the next level. Remember last week I taught you how the heart works in sequence? Do you still remember? Can you remember using your hands? Okay, everyone try again. How does the heart work? Just one side of the heart. Huh? So imagine now we are looking at the left side of the heart. Right? Can you remember the sequence? Ready? Please practice. You must get very familiar with this. Huh? So, atrium contract, ventricle contract, both relax. Try again. Atrium contract, ventricle contract, both relax. Stop, stop, stop. Stop, stop, stop. Stop, stop, stop. Now, do it with a partner. A complete heart. Okay, Rohit and I will complete one heart. Ready? Yeah? We'll die, we cannot work together. Ready? Go. Stop, stop, stop. Faster. Okay, faster? Okay, cardiac arrest. Okay, so that's how the heart works. Okay, get into the groove of it. Today I'm going to introduce to you the terms, the three phases that the heart goes through. Okay? So there are broadly three different stages that the heart will go through. Number one, so we call the first stage atrial systole. Second, ventricular systole. Last but not least, ventricular diastole. When you see the word systole, it is just another word for contract. Contract. If you see the word diastole, it means relax. These are the three phases that I got you to practice last week using your hands. Okay, there is a sequence to them. So, in atrial systole, the atrium contracts. Ventricle, relax. Here, the atrium relax, ventricle contract. Last but not least, both the atrium and the ventricle relax. Okay, I expect you to know the 3 phases of how your heart works. Where can you find this in your textbook? Actually, we put it into words, so it's very chunky. Okay, but I tried to simplify it by us doing demonstrations in class, as well as quick practice with your hands. Okay, but if you want to know where to take down notes, you can scroll down to this particular page over here when you have the 3 different phases. Okay, atrial systole, ventricular systole, ventricular diastole. You can find that on page 10 of your notes. Oh yeah, you help me press record, right? Okay, thank you. And if you are comfortable, you practice enough with the hand, then you should be able to attempt the CA question. It gave you 4 different images. Are you able to sequence what comes after what? Okay, for those that are done, may I get you to sequence what comes after what? Without using your textbook, just use your hands and memory. Okay, 4 different snapshots of the cycle. People will refer to these 3 phases as the cardiac. Every time you hear the word cardiac, means it has to do with the heart. Cardiac cycle. We say it's a cycle because after we are done with the last stage, we go back to the first step. And it repeats itself over and over again. From the day it first started beating your mom, the last day you will live on this earth. Cardiac cycle. So try with your friends now, very quickly. Give you 2 minutes. Could you sequence PQRS? What comes after what? Okay, identify the stages based on what we've written on the board, as well as what you practice with your hands. We purposely just put in 1 more snapshot to make things a bit tougher. Okay, once that, then I'll just call upon one person to share their answer. What do you go on? SPRQ. If you're done with A, may I get you to do part B? What causes the blood to move from one chamber to the next chamber? What causes it to move from atria to the ventricles, then from ventricles out via the pulmonary artery or the aorta? What's the primary force driving them? what is yours? What is your sequence? Okay, so what's the sequence? Perhaps I'll ask. Jeanette. Yes, Jeanette. Could you share with the class what is the sequence you've taken? Jeanette says, let's start with S, then we go to P, then we go to R, then we go to Q. Let's try to match these three phases. One of them is extra, right? Okay, so which is which? Atrial systole, atrial contract, ventricle relax. Which one best represents first one? R. R. Possible? Yeah, I think that best represents trying to show the atrial contract, then the valve open, right? Then it goes to the ventricle. Okay, so this one kind of represents R. What about ventricular systole? Which one best represents? Q? Yeah, kind of Q. Ventricle contract. Notice how these valves over here have to close to prevent it from going back into the atrium. Then the two small valves on top open up so they can go out via the pulmonary artery or the aorta. Okay, so Q kind of represents that. Last one, ventricular diastole. Both relax. Which one best represents? P. Okay. Personally, I feel P and S, if you all had trouble differentiating, is not too bad. Because P and S, they are kind of in almost the same phase, just slightly different times. Okay? Both are kind of in the phase of relaxing. I understand why many of you may have chosen S, then followed by P. That's fine. Because you see, it looks like the blood is at the blood vessels, then it comes into the atria. I think that's okay. Yeah? I noticed that some students may have done this instead. So rather than S, P, R, Q, you do like any other way. S, P, R, Q. Technically, because this is a cycle, you could have started from any point. Okay, what do I mean by that? If you had done instead Q, S, P, R, also can, right? It's a cycle. If you had done instead, what am I doing? I'm shifting things up. If you had done a R, Q, S, P, that's also fine, right? It's just that the way we taught you almost feels like this is always step one. But what is step one? We don't know, right? From the day you're inside your mom, where your heart first beat, you actually don't know what was the first step. Okay, so we don't know. But we teach it this way because it's easier to simulate. But actually, it was fine if you started at any point. It is a cycle. Okay, for simplicity's sake, SPRQ is quite a nice place to start. Okay, so what causes the blood to move from one region to the next? What's causing it to move from atria to ventricle? Then from the ventricle out of the blood vessels. Kiran? Fair enough. The relaxation and contraction of the ventricle and atria. Okay? So you may want to write that down. I'm only going to say it verbally. Relaxation and contraction of the ventricles and atria. That's what's causing blood to move from one region to another. If that doesn't happen, blood will not flow. I find it amazing. Just press your thumb against your wrist. You can feel the power of your heart. You press the correct region, press hard enough, then you'll feel it. Or you can press over here at your neck region. You should feel that one should be more powerful. because it's closer to the heart. Yeah? So you try to feel that your waist area should be weaker, it's further away from your heart. What are you doing? Oh, shouldn't you feel something here, is it? Okay. When you press here, or you press here, you're pressing on your blood vessels. So you will feel that pressure. But if you press on your chest over here, where your bone is, your bone over here got no blood vessel. So you won't feel anything. Yeah?
Feel it.
You cannot. Unless you can reach yourself, can reach between your ribs, press a bit deeper, then see you can feel the blood vessel there, then maybe you'll feel something. But I tend to be able to only feel where you can see blood vessels. Okay, so that's PQRS. The next stage of our lesson will be slightly difficult. I would say this is the toughest part of this chapter. But if you find it easy, or if you follow through with me in this lesson, you will find that it's not that difficult. It's just a myth. It just looks difficult. If you can appreciate the cardiac cycle in its 3 stages, now I want to show you a graph version of this. The graph version is the part that kills students. Every time you see the graph, they're like, oh my god, it's so complicated. But it's really not. If you scroll down, you will see a sample of this graph. I'm going to guarantee you 100% that you will see this graph in your final year exam. Even if I'm not setting the question, I can bet you the next teacher setting it will put this graph in. Yes?
We have to draw it.
Ah, okay. So how you ask you have to draw it. Good news is we'll never ask you to draw it. So, what do you need to be able to do? You just need to be able to interpret this graph. Okay? Okay. I've listed down 1, 2, 3, 4, 5, 6, 7. 7 things that a teacher can ask when they show you this graph. I cannot imagine anything else they can ask other than these 7 things. So, 2 ways you can study this. Number 1, you can follow with me, then we use our logic, use pure logic to answer and find out where all of these takes place. Or number 2, if you don't understand the logic of it, then you have to put into your memory space 7 extra things. Right? But I want to show you, if you use your pure logic, actually you can find out the answer to these 7 questions very easily. First and foremost, when we look at this graph is showing you, as you can see on the left hand side, pressure. Pressure inside 1/2 of the heart. So let me just focus our attention now. This graph is just showing you the pressure inside 1/2 of the heart. Specifically, it's just showing you the pressure inside left side of the heart. Okay, so I'm erasing everything else away. Number 2, how many graphs do you see in this image? You will see a total of 3 graphs. Yeah? Because these 3 graphs are generated through a very interesting experiment. People put little sensors in 3 different regions in the heart to generate and record the pressure changes. What do I mean by that? The first graph you see in blue, I would like you to label it. This is the pressure inside the left atrium. So imagine we put one sensor over here. That's what generated the first blue graph. Perhaps you can write that down inside your CA. Yes, Maya?
But how do we, like, if they give us a graph, how do we know which one is the one in the atrium, which one is the one in the ventricle?
Oh, that's what I'm teaching you now. Yeah. Okay? So I just said the blue graph over here, the lowest one is always the atrium, in the left atrium. It could be the right atrium or the left atrium, depending on whether we tell you this graph's on the right side of the heart or the left side of the heart. The next graph, you see the black graph that's very big. That graph represents the pressure inside the ventricle. Yeah, I tried to put a dot, be pointless. Okay, so this one is the black graph. Okay, when come exam time, we will not show you colors, it will just all be black. Right? So you must take the location. But in this case, I'm just going to label it color so you know what we're talking about. Blue dotted graph. Last one, the red graph you see there is a graph of the big blood vessel leaving the ventricle. So that's the graph, the red dotted one. Represents the pressure in the aorta. Okay, that's the first thing that you need to be able to identify. What are the three different graphs representing? Do you notice that every point that we're measuring the pressure from is actually separated by a valve? Look, the left atrium and the left ventricle separated by a valve. The left ventricle and the aorta separated by a valve. We're purposely measuring the pressures in these three regions because they are separated by the valves. Okay. Next stage, I would like you to identify. Okay. First three are A, B, and C. I will teach you. D, E, F, G, we will find out together. Okay, so first step, atrial systole. That means when the atrium contracts, I'd like you to label it as within this orange region here. This orange region here is atrial systole. Yes, Hoya?
But I meant so the biggest graph will always be the ventricle.
Correct. The biggest graph will always be the ventricle.
Then the one at the bottom will always be the atrium.
Always be the atrium. Your graph goes something like that. It's a blue graph and a red graph. Okay, this tiny graph over here, you see go up, down, and down again. Okay. So this very first region, this is your first step up, where you first squeeze the top part, atrial systole. And it makes sense. When the atrium contracts, the pressure in the atrium rises a little bit. Okay? So the graph all makes sense, huh? Next, from around here, the blue region, to here, the entire blue region, this is ventricular systole. You see you are following the sequence? That's why you get very comfortable with the hand pressing first, huh? So you can label the next phase. The next phase, the blue phase, you can label that as ventricular systole. That means the remaining orange phase, you can label it as ventricular diastole. If you forget, then just remember left to right is 1, 2, 3 log. Okay, left to right, just follow 1, 2, 3. The typical motion that you do with your hands. Yeah, so that you know the hand pumping is a very powerful tool to help you remember. Okay, it is D, E, F, and G that students find very hard to figure out. If I would like to show you that you can use pure logic to figure this out. Okay. When does a valve open or close? Truly, a The valve opens and closes when there's a difference in pressure on either side of the valve. Okay? For example, you know your door, right? You only open or close if, for example, someone gives a push on one side, or if there's a strong gust of wind on one side. If there's no difference in force on either side, the door won't open or close. The same goes in our heart. So the very important rule to understand how this all works is valves open or close when there is a difference in pressure on each side. Okay, this is what we also implicitly figured out last week when we were playing with the valves. Why do I say this? If I ask you a very simple question now, when the atrium contracts and the ventricle relaxes, the pressure inside the atrium will be high, right? And the pressure in the ventricle will be low, right? This valve will open or close. Does it make sense that it open? Yeah? There's some logic to it, right? Okay. So if you understand this logic, right, the graph that you are seeing on the screen follows the exact same logic. Now I'm going to show you how right now. So I need everyone to pay attention. Okay, please follow me right now. I want to show you how to interpret this graph. When a student first sees this graph, they will look at it as all three at one go. But don't look at it that way. I just want you to focus on the black graph. Okay, everyone focus on the black graph, and we will move left to right. These are graphs showing the different pressure changes in the graph, in the heart. So look at this. This is, the black one is the pressure in the ventricle, right? Okay. So I ask you, when the pressure in the ventricle becomes higher than the pressure in the atrium, which is the blue graph. I say again, when the pressure in the ventricle becomes higher than the pressure in the atrium, which valve will open or close? You may look at this particular model over here. When the pressure in the ventricle becomes higher than the pressure in the atrium, which valve will open, which valve will close? You use your pure logic. Okay, please discuss with your friend now. Which one do you think is the answer? Do you think it's D, E, F, or G? MCQ question. When the pressure in the ventricle, the black one, becomes higher than the pressure in the blue graph, which is the atrium, which valve will open or close? Yes? Say again, ventricular systole? Correct. So ventricular systole consists of all the graphs in this phase. Yeah? Okay, I would like everyone to think, if you work this through in your mind, I guarantee you don't need to memorize anything. Okay? When the pressure in the ventricle goes higher than the pressure in the left atrium. So this is how it's going up. When the pressure in the left ventricle becomes higher than the pressure inside the left atrium. So at this point over here, which valve, this one or this one, is opening or closing? Okay, so I give you an example. When the pressure inside the left ventricle exceeds the pressure inside the left atrium, since we want blood to only flow in this direction, this valve should close. Okay, this valve should close. You see the logic of it? When the pressure in the ventricle becomes higher than the pressure in the atrium, when the pressure is higher than the pressure in the atrium, blood will want to flow in this direction, but we don't want it to flow in that direction. So we should make sure that it closes, so that it cannot go backwards. Yes?
Wait, does the valve open like this or like this?
The valve can only open this way.
This way,
It cannot flip the other way.
Wait, so when the pressure is higher in the down there, right? Why will it open this way?
It doesn't know. It will close off. So when the pressure in the ventricle is higher than the pressure in the atrium, this valve will close.
Was it open in the first place?
It was open in the previous step.
Oh.
Yeah, we're starting off from. Where are we starting off from? Because we have entered ventricular systole. the blue part of the graphs, this is when the ventricle contract. Yeah? When the ventricle contract, this valve shouldn't even be open, it should be closed. How, yeah?
Like, isn't it like every time atrial systole, then the bicuspid will open? Like, isn't it like when it's atrial systole, it will open?
In this phase, right?
Oh, like in every single heart.
Oh, no what? Because if you know how the heart works, remember when the ventricle contracts, which is the blue part onwards, when the ventricle contracts, this valve should close, right?
Right, the ventricle systole.
Correct. But you see, at this point when the ventricle graph exceeds the blue graph, it is when ventricle systole starts, right?
But like, the atrial systole, when it happens, the bicuspid valve will always open. So why do you have to like go and see what point? It's just when the atrial systole.
I agree with you in atrial systole. In the orange part over here, the bicuspid valve will be open. I agree with you. But the moment we transit into the ventricular systole, the bicuspid valve need to close, right?
The question is like, oh, where identify when is it open and closed? Then isn't it during?
Oh, okay. So usually, when they say identify on the graph, when the following is taking place. Oh, I see. Okay. So perhaps maybe rephrase the question. Can you identify the intersection points where the valve will first open or close? Okay. And this point over here is when the bicuspid valve first closes. Okay. Okay. So that's the first point. So that's when it first closes. Next, when the pressure in the ventricle becomes higher than the pressure in the aorta. When the pressure in the ventricle becomes higher than the pressure in the aorta, will this valve open or close? It should open. Right? It should open up. You notice that whatever we are doing here is exactly what you learned last week about how the siphon works, how the pump works. Right? Because in the blue phase of ventricular systole, you need this big valve to close and this one to open when the ventricle contracts. This is what we learned last week, right? When we were playing with the pump. So on your part, what can you do? You can label at each intersection point which alphabet, D, E, F, or G is happening. So far we've used up 2 alphabets. If you feel comfortable, then you can try and figure out at the next 2 intersection points which valve will open or close. Okay, what's the first intersection point? Is D. You put it as D. The second intersection point is F. No, am I wrong? Aortic valve opens. Yeah, should be okay. Yeah? Okay, so what's the remaining 2? Oh, this is not D, right? Okay, this is E. Okay, thank you. E is when the bicuspid valve closes, and then this is when the aortic valve opens. So the remaining half, Okay, can you try the remaining half? When the pressure in the ventricle becomes lower than the pressure in the aortic valve, what will happen? When the pressure in the ventricle becomes lower than the pressure in the atrium, what valve will open or close? Yes?
Doesn't D start at like the very start?
This one? D, ah?
No, D like at the start.
Oh, D will happen over here and it will stay open all the way until this point it closes.
So you can also say D is there.
Oh no, but D first opens here. Yeah? But it remains open all the way until when E occurs. Okay, can you try with your friends? What will open or close here? What will open or close here? Okay, then that is, these are the 7 different kinds of questions you can get if you were to see this graph. Do not need to memorize how to draw this graph. You just need to tell me when certain valves open and close, when are the 3 phases of the heart. You're talking about ventricular diastole. It starts from the origin. Oh, you are saying that. Okay. I think your graph is slightly out. It's usually the intersection is moving. You understand that there's some confusion because when you look at the red and black graph, the black graph over here doesn't seem to intersect with that. I think it's slightly displaced. You take the red graph, you slightly shift it to the left, right? Then it will be more correct. Okay? If you shift the red one slightly to the left, or the black one slightly to the right, then the black will intersect at this point over here. Okay, so what's the remaining 2? Let's first start with this point up. What's going to open or close? Okay, what are the 2 parts involved? 2 parts involved are the aorta as well as the ventricle. Okay, so if it's the aorta and ventricle, so we are really looking at this region here. When the pressure in the ventricle becomes lower than the pressure in the aorta, blood will want to flow back into the ventricle, but we don't want that to happen. So therefore, this valve needs to close. Okay? This valve needs to close. So the answer for this would be G. When the pressure in the ventricle becomes lower than the pressure inside the atrium, so when the pressure inside the ventricle becomes lower than that inside the atrium, then blood will want to flow in this direction. Is that the direction we want? Yes. So therefore, the valve will open. So D. Okay? To summarize, to interpret this graph, you don't look at all 3 graphs at one go. Follow the flow of the black graph. Follow the flow of the black graph. And ask yourself the question at every intersection point. When the pressure in ventricle is higher than atrium, which valve do I want to open or close? When the pressure in the ventricle is higher than the aorta, which valve do I want to open and close? When it's lower than aorta, which valve should open or close? When it's lower than the atrium, which valve should open or close? That's how you should follow the flow of the graph. Don't look at all 3 at one go. Okay? I guarantee you 100% you will see this graph again in your worksheet, in your exam. So get familiar with these 7 kinds of questions that will come up. Okay? Next lesson I see you, which is tomorrow. We'll play a quick Kahoot, and then Kahoot will now include the graphs also to interpret. Okay? Take some time to digest this because this is the toughest part of this chapter. Okay, but you find it quite understandable. Actually, it's not that tough at all. And that is all for today. Just take some time to consolidate your learning. Yeah.